Hello friends, Namaskar. I am here to discuss about the different types of satellite orbits. As I am sure that most of you must have seen or heard about the orbits like lower Earth orbit, medium Earth orbit, or geosynchronous orbit in the news. So let's discuss about what they are, what their means, advantage or disadvantage in the terminology of space. So let's discuss. So, following are different types of satellite orbits: lower Earth orbit, medium Earth orbit, geosynchronous orbit, and high Earth orbit. A satellite may orbit around the Earth in the different planes. For instance, an orbit that is directly above the Earth's equator is known as equatorial orbit, while the one that passes over the both poles, that is north and south poles, is known as polar orbit. Other orbits are referred as inclined orbits. The orbit may be circular with the center of the circle at the center of Earth, or elliptical with the Earth's center at one of the two foci of the ellipse. The altitude of communication satellite can be geostationary Earth orbit, that is GEO, medium Earth orbit, that is MEO, or lower Earth orbit, that is LEO. So different types of orbits and their distance from the Earth's surface may be understood as lower Earth orbit, that is the 50 to 1500 altitudes from the surface of Earth to 2000 kilometer distance, also considered as low Earth orbit. Medium Earth orbit, that is the altitude from 5000 to 12,000 kilometer, even 20,000 kilometers in the case of GPS. Geosynchronous orbit, that is the altitude from 35,786 kilometer, or it you can say that is 22,236 miles. And another is high Earth orbit, that is HEO, that is beyond 35,786 kilometers. So let's discuss in detail the lower Earth orbit or low Earth orbit. Low Earth orbit satellites are often in polar orbit at altitude of 50 to 1500 kilometers, and the orbital period in the range of 95 to 120 minutes. Lower Earth orbit satellites try to ensure a high elevation for every spot on Earth, thus providing a high quality communication link. The maximum time that LEO satellites are visible from a fixed point on Earth is up to 20 minutes. LEO is further classified into little LEO with low bandwidth services almost 100 bits per second, big LEO almost 1 kilobits per second, and broadband LEO almost 2 millibits per second. Let's discuss about the some advantage of LEO. It can provide true globe coverage and efficient use of spectrum. Due to lower pulse loss, use of smaller terminals become possible, and the propagation delay is very low, that is 10 milliseconds. There is also of course some disadvantages of LEO. The mismatch of the orbital period of satellite and Earth results in serious consideration of Doppler effect. It requires large number of satellites for whole coverage and high probability of handover during a call. Failed satellites required to be replaced regularly because of their lower lifetimes. So friends, now discuss about the MEO, that is medium Earth orbit. Medium Earth orbit satellite can be positioned somewhere between LEO and GEO at an altitude of around 5,000 to 12,000 kilometers above the Earth's surface with inclination towards equator plane. So far, there have not been many satellites in this orbit, but some upcoming systems use this orbit. The orbital period of MEO satellite is about 6 hours. The visibility of satellite from a fixed point on Earth is about 60 to 100 minutes. So friends, now discuss the advantage of MEO. It can provide true globe coverage. It is possible to use smaller terminal because it provides lower path loss due to less distance. It provides medium propagation delay around 80 milliseconds, and of course MEO can cover large area, thus requires less handover. So friends, now discuss about GEO, that is geostationary earth orbit. Geostationary earth orbit satellite is the most popular type of communication satellite. If the orbital period of satellite exactly matches the orbital period of Earth at an altitude of 35,863 kilometers above the Earth's surface and rotates in the equatorial plane of the Earth with angular velocity of 3075 meters per second. Such an orbit is called geosynchronous orbit. When the inclination and the eccentricity of the orbit are zero, the satellite appears stationary to an observer on the ground. Thus, the orbit is termed as geostationary orbit. Advantage of GEO are: since the orbital period of satellite and Earth are almost same, the problem of Doppler effect does not occur as relative motion is zero. The GEO satellite covers most of the inhabited portion of the Earth, excluding only the area near the North and South Pole. Disadvantage of GEO are: it provides relatively large propagation delay of 0.24 seconds. This affects voice and time data protocol. Relatively large path loss due to large distance traveled by signal. Relatively high launch cost, and polar region and far northern and southern hemispheres are poorly served by geostationary satellites. Now discuss about HEO, that is high Earth orbit. Those satellites or space mission we send across the Earth's orbit beyond 35,786 kilometers are called as high Earth orbit satellites. For example, Chandrayaan 1st, Chandrayaan 2, Mangalyaan 1st, and Aditya mission, etc. LEO satellites at polar satellite, MEO satellite at inclined or transitional satellite position, and GEO satellite at equatorial position for their own work. This must be noted. So now discuss about polar versus polar sun synchronous orbit. Polar satellite cannot be used always. Friends, polar satellite cannot be used always to take images of the Earth's surface. Only for certain time period, the satellite will be only in front of sun. For rest of the time, due to planetary movement, sun and Earth position change, satellite will see the shadow of the sun on the Earth's surface. The only solution to this problem is polar sun synchronous orbit. So polar sun synchronous orbit is where the revolution of satellite is always in front of sun as result of changing their own inclination angle at every revolution. Since in this orbit, satellite appears to follow the path of sun at every moment of time. It is called as polar sun synchronous orbit. This orbit also called as dawn to dusk orbit because satellite trails the Earth's shadow. The shadow is casted on the opposite side rather than the side where the sun shines. Since the satellite never moves into the shadow, the sun appears to always shine on it. due to closeness of satellites to the shadow. The part of the Earth the satellite is directly above is always at sunset or sunrise. Hence, the orbit is called a dawn to dusk orbit. This enables the satellite to always have its solar panels toward the sun. Generally, sun synchronous orbit are medium or low orbits, and you might have heard the radar sat. Canadian satellite is an example of a satellite in a low sun synchronous orbit. Radar sat is in orbit at 798 kilometers above the Earth at an angle of inclination of 98.6 degree to the equator. As it circles the globe from pole to pole to keep its solar panels facing the sun almost constantly, radar set relies on its dawn to dusk orbit. Radar set can henceforth rely mostly on solar power rather than batteries. Friends, there is a important topic, GPS orbit and semi-synchronous orbit. So let's discuss in brief what is GPS or semi-synchronous orbit. So GPS orbit is an elliptical orbit at an altitude of 5000 to 12,000 kilometers used for navigation purpose. A constellation of 24 to 36 satellite in MEO orbit, inclined or transitional in position, will be utilized to cover world navigation in global positioning system like Navstar or GLONASS. Three geostationary satellites can be used to cover the entire surface of Earth except polar area. So it cannot be used in global navigation system in a country like India, those which are near to equator. For regional GPS we can use GTO geosynchronous transfer orbit and GEO geostationary orbit in combination, for example Gagan and IRNSS. So friends, these are some points and topics I tried to discuss in brief, and I hope you will learn something. Thank you friends. Have a nice day.